So now we're in the details of the actual scripting language and how we use the APIs to interact with this Google Sheet, and also how to execute the commands. And so I'll walk through the various functions. I have it broken up into sort of three buckets. This first one is the main one, powering the smart charging spreadsheet that I showed in the previous videos. So the first one, the first thing you have to do is get a token, and that's really a fancy way of saying this is how you gain access to the APIs. And this is the format. If you look at the documentation on the website, I had showed it earlier, when you want to reach out to the cars and get information, there's a format you have to follow. This URL you call, and you pass in a bunch of parameters, and this is the format. I found these mostly on, Stack Overflow or other Google sites searches I did. And the client ID, client secret, that was something I had to dig around for. Again, it was on a different website. Here it's another Tesla API website. There's only, I think, 2 of them out there, but this one, and somehow someone was able to reverse engineer these 2 values, this client ID and client secret. So I was able to find that from this website, and once I copy those in here, you have to put your email and password. This is the email and password you use to get through the app, your Tesla app. And obviously, I always blank them out just because there's, I feel, a kind of a risk here, because there isn't, as I mentioned earlier videos, there isn't 2-factor authentication. So if someone has your password, that's it, right? There's no, with 2-factor, you have to have your phone. They have to have something like your phone too, because it'll ask you for your password, and it'll send like you a text message with like a special code. So Tesla hasn't implemented that. So really, if you just have email and password, you can gain access to someone's car. So that's why I felt uncomfortable sort of storing this in here, where even it's Google, I just didn't want to keep that here. But you only need to really get it once. I think the token that you get back expires in like 45 days or so. So every once in a while you have to go back in here and rerun this to get the latest token. So it's not the most friendly or easy, but again, this is really more for fun, I guess. Once you get the token, now that's just as dangerous, right? Because with that token, you can access the car without the email and password. And again, there's no 2-factor authentication, so you got to really be careful once you get that token back from this call, this command call. And then, unfortunately, you do have to store that. It's not encrypted or anything like that, so you got to store it, but just be careful not to share or anything like that. And then, so this is the simple one to get the token. You run, once every month or so to get that. And then this command will list out the vehicles. Again, I'm going off of the Tesla APIs, the documentation, right? This one, owner-API, vehicles. Again, if you go out here to list vehicles, right? This is how I found this, the format of the URL to call. And then so you call that, you pass in, again, this is the syntax I found to pass in the token that you got. This access token is what you got back from running this other function. And then you embed that in there. I had this logging for debugging, but you get this response back, and you get like an XML looking, an HTML response, which is kind of embedded in a structure, and it has vehicle information. Again, if you look at this documentation, you make this call, the response looks like this, and it passes back all this information. This is an example, and what you need is the vehicle ID, which surprisingly is not this value called ID, it's called ID_S. Again, I only found that because others have found this out. So this is your vehicle ID. This seems to never change. So that's what you use to call. You'll see in the other functions I walk through, that's what you use to call, get the information per vehicle. So once you sort of get that information, you probably never have to run this again, unless there's new attributes that come out, and you can, through that. And so this one's called Wake Vehicle. I called it Wake Vehicle, and so I think the app, the mobile app does this too. But occasionally, if you send a command or try to get information from the car, it's usually asleep. The cars, to preserve battery life and range, battery range, they certainly will go to sleep, within a couple minutes. So if you try to send a command, you'll get an error back. So I'll show you sort of how I do this, but you have to send a wake command to essentially, turn it on, and then you can run the command again, and then you should get a response. It doesn't always work, but it works like 90% of the time. This is the command once I figure out when to start charging according to the calculation of the smart charger. Again, you can see it takes both of these functions take in the value of the vehicle ID, which I showed you can retrieve from the other function, and you sort of splice in the vehicle ID, and then it sends a command to start charging. So this is the main thing called on the trigger, the timer that I set from the calculations above. And so obviously you write it this way so that you can pass it if you have more than one vehicle. And then this one I called to get the charge state, and this URL to get the charge state with the vehicle ID. This gets you information like what's the battery range, what's the, is the car plugged in, is it charging? So that has a lot of information that I use to put inside the sheets, both in terms of the metrics and the telemetry of how much miles have been driven, also as well as to run the calculations for when to do the charging to finish at a particular time. Going back up, the drive state, I use this to get GPS coordinates. The GPS coordinates I'll show you in the function layer above. It's for a calculation to let me know if the car's at home, because some of the logic I run that says if the car isn't at home because someone's out or whatever, I don't bother setting the charge time because it's probably not plugged in. So I use this function for a subset of the data called drive state, which really gives you GPS location. And there's a formula you have to do a calculation. I'll run through that as well to figure out how far the car is away from a particular location. And as I mentioned, this is the calculation. This function called get distance from home, and you pass in from, after running this drive state call, you get latitude and longitude of this particular car. And then this formula is called, I don't know how it's pronounced, Haversine or Haversine formula. It essentially finds the distance on a sphere between 2 points, and supposedly it's not very accurate on long distances, but within a short distance it's pretty accurate. And all I'm trying to do is figure out like if the car is within a quarter mile from the house, right? And you could set it to some arbitrary value. You can set it 100 meters or whatever, but I don't know, I just set a quarter mile just because I didn't think it was going to be more accurate than that. And so this is the formula. You can look it up on, there's a lot of Wikipedia and different sites that show you how to do the calculation. So I won't go into that, but this is effectively the calculation using the Haversine formula to calculate the two distances. So all it does is from the car's latitude and longitude, and then this one you can get for your home. You can get that off of Google, actually. This is your home or whatever, your workplace, whatever location you want that you calculate from. This is that location's latitude and longitude. It'll do all this calculation, and then it'll return a distance. And the distance can be in miles or kilometers, so that's really set by this variable called r, which is, I have it all set above, but r is the radius of the Earth in miles or kilometers or whatever, so that will tell you the distance in miles or kilometers. So that's how you do the calculation. And then these two functions, I have two vehicles. As I mentioned earlier, I have a Model 3 and a Model X. And so the reason why I have it in these additional functions is because of the way the car sleeps. So when you call this function, as I showed down here, when I just say, hey, charge it, and I send this command, you'll just get an error back, most likely, because the car's asleep most of the time. So what happens is it throws an error, and this thing called the try catch block, it throws an error, and then I log that error just in case. And then I run this function, as I showed you earlier called wake vehicle. So it sends the vehicle command to wake down here, and then it should wake it up. And then I also give it a command to wait about 30 seconds. And the waiting, the reason is because sometimes if you go in the Tesla app, you can see that it doesn't wake immediately. It takes 5-10 seconds to awake before you can run a command on the phone. So this is effectively waiting to let it fully wake up, and then I just rerun this. I rerun this command again, so it'll charge. And this seems to work most of the time. There are some exceptions when this doesn't work. Sometimes the car, I don't know, people's reported it's like it's in a deep sleep or something like that. I don't know if that's the correct term, but it's in some kind of sleep state where it doesn't wake up, and that happens sometimes. And I thought about some functionality to run it like a maximum number of retries or spacing the retries out, but it turns out that using Google Scripts, there's a kind of a built-in safety. No function can run longer than I think like 3 minutes or something like that. So this will just kind of go in an endless loop. And because I wait every 30 seconds, it's not pinging it constantly. So 30 seconds, into 3 minutes, you can do the math, but it runs it like a dozen times or so, and then eventually it wakes up and then you charge it. Again, once in a deep sleep, it won't do it. So if you're really worried about it not charging your vehicle, it has to be like dead on every single time, and you need all the miles possible. I don't use, like I said, I charge the car to 70%. So if it doesn't charge one night, it's no big deal. But if you have a situation where it has to be charged fully or to whatever percentage you need every night, and if you skip a day, you can't get to work tomorrow, I really suggest you don't use this function, or this kind of hobbyist kind of approach to doing this charging. But like I said, I have the luxury of not having to have a full charge. I can skip a day or two, is no big deal. So this is how I handle this try catch block and this wait and waking sort of structure I have. That's how I wake the vehicle up and then send the command one more time, and then like I said, it works like 90% of the time. And then this is just another sort of a higher level function I wrote to give a yes/no answer versus me having to do the math every time. But you can see here that I get that formula to say how far is the car from, what's the distance from my home, and then I just happen to set, like, if it's less than a quarter of a mile, then it's considered home, and if it's not, then it's not home.